Welcome friends to my YouTube channel Sommo Physics. One of my friends told me to discuss about few things. So today I am going to discuss those things. So before I start, I want to say that if you don't subscribe my channel, then kindly subscribe it and also share this and also give like. So let's start. So the first question which one of my friend told me to discuss is the basic difference between isothermal and adiabatic process. What are the basic difference between isothermal and adiabatic process? So there are so many differences. First of all, in isothermal process, the temperature remains constant, and in adiabatic process, the entropy remains constant. How? We know in adiabatic process there is no exchange of heat between the system and the surroundings. So from second law of thermodynamics, we will see that if dq is the amount of heat absorbed at temperature T, then the increase in entropy ds is equal to dq by T. For adiabatic process, dq is 0, that means ds is 0, that is s is constant. So first difference is that in isothermal process temperature remains constant, and in adiabatic process entropy remains constant. This is the first difference. The second difference is that isothermal process is a very slow process, whereas adiabatic process is a faster one. Third process is that during isothermal process, Boyle's law holds good. That means PV equals to constant. But in adiabatic process, the relation P into V to the power gamma equals to constant. This relation holds good. What is gamma? The ratio of two molar specific heats, that is Cp by Cv. Now another difference we can say that in case of a isothermal process, there is no change in internal energy. Why? Because we know that internal energy is only a function of temperature for a perfect gas, if we take perfect gas. So since the temperature remains constant, the change in internal energy is always 0. But in case of a adiabatic process, internal energy may increase or decrease depending upon whether the process is compression or expansion. If we take adiabatic compression, then the temperature increases, and if we choose adiabatic expansion, then the temperature falls down. So these are the basic differences between isothermal and adiabatic process. So this is one. Now another thing, it was asked by a higher secondary student that what are the basic features of internal energy, but what are the properties of internal energy. I told about internal energy in my second video. If you don't see it, kindly see it. I told it in my second video, but now I am also tell about this. I again tell about on this. So we know that internal energy is nothing but the total energy contained within a volume, that is summation of all energies. For example, we took the electron revolving around the nucleus. There the electron has a potential energy due to the attraction with the nucleus. The electron has a translational kinetic energy while revolving around the nucleus. The third one is that if we imagine an axis through the nucleus, then electron rotates around the nucleus. So there must be a rotational kinetic energy. And besides rotating around the nucleus, the electron also rotates about its own axis. So there are several energies in the system, and the sum of all the energies are the internal energy. But in practicality, we take internal energy as the sum of mechanical energy, that is translational kinetic energy plus potential energy. Other energies are so small that we can neglect it. So we can write simply U equals to T plus V, that is the total energy of the system. This is the actual fact. Now, basic features of internal energy that also was taught by me in the second lecture. What are the basic features? First of all, it is a single valued state function. Why single value? Because it has only one particular value in a given state. Suppose a system moves from one initial state to final state, and in the initial state it is ui, and in final state say it is uf. So in a particular state we see that there is only one value, so that is called single valued. And state function is why? Because the internal energy only depends upon the initial and final state of the system, no matter through which path we move from one state to another, no matter. So it is a state function. The second one is that I told that we can't measure the absolute value of internal energy. We can only measure the change if we move from one state to another. That is, absolute value of internal energy cannot be measured. Only we can measure the change in internal energy. The third one is that for a perfect gas, it is only a function of temperature only, because we know that for a perfect gas, there is no force of attraction between the molecules. So there is no potential energy. The entire energy is kinetic. And if we take 1 mole gas, then its kinetic energy will be 3 by 2 RT. That is, internal energy is 3 by 2 RT. So it is a function of T only. Okay. Fourth one is that in case of a cyclic process, the change in internal energy is 0. What is cyclic process? If a system moves from initial state and returns to the same state via different paths or cycles, it is known as cyclic process. That means starting from a particular state, a system again come back to the initial state via various cycles. So this is called cyclic process, where the change in internal energy is 0. Okay. So these are the basic features of internal energy of a system. Okay. Now another question somebody told me to discuss about the limitations of first law. It was also taught by me in the previous lectures, that I told that in case of a first law, there is a transformation between heat energy and mechanical work. There is a conversion. W is proportional to H. There is a transformation of heat energy into mechanical work. But how much amount of heat energy is converted into work, and under what condition and in which direction the transformation takes place, that we don't know. How much amount of heat energy is converted into work, that we don't know, and under what condition this transformation takes place, that we also don't know. I will discuss this in second law of thermodynamics, that what are the conditions under which heat transforms into work, or how much amount of heat is converted into work. that I will discuss on second law of thermodynamics. So this is the main limitation, that how much amount of heat is converted into work and in which direction the transformation takes place, that we don't know from first law of thermodynamics. So these are the questions that are asked by various students to recapitulate. Okay, so I hope that your confusion is clear. Now you get your answers. Okay, so thank you.